name's Ollie and I'm your host for today. So before we start, I just want to say a massive thank you for signing up to this year's competition. And for those of you who don't know what I'm talking about, this is the Leaders Award competition, where we ask the question, if you were an engineer, what would you do? Now, pupils from the age of 3 to 19, anywhere in the UK can join in, and every person who takes part will receive a named and graded certificate from a real-life engineer, just like the ones that we interview. The deadline for submissions is March 2025. You've got a bit of time, but make sure once you've finished the competition in class, you send those applications on to us. And during these interviews, we're going to be speaking with engineers who work on loads of different projects, all of them showing the wonderful, interesting, and exciting things that happen when you work in engineering. So our special guest today is going to start with a presentation about her engineering journey, and then we'll open up to the audience for questions. So if any questions come to you at all while Andrea is speaking, please do write them down in the chat box and we will get to them after the end of the presentation. But make sure you put your questions down. I'm sure loads are going to come to mind as Andrea chats. But for now, I'm going to hand you over to Andrea, who will start with her presentation. Over to you, Andrea.
So, as Ollie mentioned, I'm a naval architect, and a lot of the times when I have a chat with students, with colleagues from different departments, the big question is, what does a naval architect actually do to start with? As I said, I became a naval architect, having studied at university, which I'll get into eventually. Why did I become a naval architect? Before I even describe what a naval architect is, early stages at school, you may find yourself a bit confused. You might not exactly know what you want to do, and a lot of the times the question is always, where do you want to go? What do you want to start studying? What do you want to work as? But actually, to answer those questions, I thought you need to initially understand, what do you actually like? What do you enjoy right now as on this day? What do you like doing? How can that lead you to making a big decision like this? So I was quite into design, arts at school. I was quite into maths and science. But especially out of all three, I was very into sailing as a sport. My whole childhood and teenagehood was very much revolving around traveling and sailing around and competing. So that drove my decision to actually build a bit of a puzzle and come to the conclusion that I wanted to become a naval architect. So what is a naval architect? What do naval architects do? So we've got here my friend Bob floating on a piece of ice, not quite sure if that is safe. That's probably the most simplified problem I've tried to display where a naval architect might assist. So it's mainly the designing, the engineering of surface vessels, submarines and other marine structures. For example, offshore platforms, fixed underwater structures or technology, autonomous vehicles. A lot of these structures, whether they're fixed or vehicles that move about, will need the involvement of a naval architect. So the design of any sort of product that a naval architect is involved in begins always with an idea. Any project starts with an idea, which then evolves going through different stages, and all these different stages are what a naval architect is involved in. In some way or form, some are more commonly done directly by a naval architect than others. Perhaps in certain areas, a naval architect is purely assisting, but they do tend to cover most of these topics. So it starts from an idea, evolves into a main parameter. Well, what are we looking at overall, high level? What can this look like in terms of dimensions, in terms of purpose? What is the whole point of this project? And what is like a bounding parametric study to it? So a general arrangement is then evolves from there. Basically, what will it include? What is it doing? Is it transporting goods? Is it a private yacht with some luxury components? Is it a technical product that needs certain equipment? And so you move on to designing what it actually looks like from the outside. What is the main coating of it, the hull, for example, when it comes to a boat. If it's moving, how are you going to move it? What kind of engine are you going to put into it? Then you move on to structures. Is it strong enough? So you look into different evaluations, different regulations. You need to prove that it will sustain different environmental conditions, different operational conditions. How long is it going to live? How are you going to maintain certain things that might break eventually? What kind of damage will be caused in different scenarios? And so all of that, again, probably along with a structural engineer, the naval architect will get very much involved. Mass and buoyancy. So how heavy is it? Is it going to sink? Is it going to float? When is it going to sink? When is it going to float? Should it sink? If it's a submarine, maybe it should sink. If it's a sailing yacht, maybe it shouldn't. So that's again another evaluation the naval architect does that comes hand in hand with stability. So how is this, if it's at the surface floating about, how does it actually float? When you move a weight, does it move very rapidly? Does it not? How does it feel? How does it react? What is your maximum loading? What is safe? What isn't? Can it sustain a certain wave? Can it sustain a certain wind speed? What are the sea conditions that you can operate in, for example? And those again all come with a lot of regulations, a lot of standard procedures, and some interesting maths, some interesting analysis that you need to do, taking into account an overall design that comes essentially together with a lot of communication with different team members. So a structural engineer, a systems engineer, an outfit engineer. And so you bring all the information together and you glue all the pieces together to do a final analysis. And then coming to the end of a design spiral, you then need to be involved in, can you actually build this? Is there anybody that can actually build this? Are there processes to build this? Do we have the right materials to build it? How long is it going to take to build? Do we need it tomorrow? Do we need it in a year's time? You'll then come into communication with different companies, different processes, and that again will influence the design, which comes again finally with costs. How much is it going to cost? Do we want to spend it all in one component of the design, or do we want to share it and evaluate how much everything is going to cost from start to end? So a lot of all of this, all of these components of the design, a naval architect is very much involved in, with other components as well. These are kind of high level areas that you tackle. So moving on, as I said, my main drive to deciding to become a naval architect was sailing. I always sailed when I was a kid. I competed. I'm from Gibraltar. Probably heard my strange accent by now. I'm from Gibraltar, and I sailed all along the southern coast of Spain since the age of about 7. And this brought a lot of thinking. You need to take care of your own boat. You need to maintain your own boat. You need to clean your own boat. And you travel almost every weekend alone with your team, with all your equipment, with all your sailing gear. And a lot of that drove my interest in naval architecture, because it's all very much down to the sports itself and the feeling of being at sea, which is very different to being, focused on numbers or something a bit more theoretical. That all comes in hand, and you need everything. But this feeling of physically doing something hands-on is very powerful. So that was my main drive. Moving on, as I said, the whole academic side of things is very much needed. And it was very interesting, probably the best years I had at university. I went to Solent University and finished my academic career with a MSc, a master's in maritime engineering and science, looking slightly into CFD, which is computational fluid dynamics, a very long word. Essentially the study of how structures react in fluids, how you can optimize things that are set in fluids. Fluids could be water, could be a gas, could be air, and so I combined that area of science with naval architecture. My studies, well, a lot of the things I covered during my studies were mainly the general design of sailing boats, motorboats, high-speed craft. Within certain projects, I also did some testing. This is not precisely my testing, but it's an example of towing tank testing that you can do, which is very much the bread and butter of a naval architect, where you look into the performance of a certain structure you design when you put it in water. And so you have a model scale of what you're designing, and you can test before you build the full scale structure. On the right side, I also did a bit of towing tank testing, in line with also hand in hand with CFD, which is computational, to look into a wave propelled autonomous vehicle. So this vehicle is designed to go all around the world and collect data and collect samples, and it will tell you things like different environmental trends, conditions in different parts of the world. It could give you water samples like contamination around the world, and it will run by itself, and it will move with the energy of a wave. And so it has these massive foils at the front part and at the back, and these foils move up and down, and the boat will essentially collect any extra energy to store, and it will use the remaining to actually propel itself. And so I looked into the interaction between these two, and I looked at how the flow moved in between these, and optimized the spacing of these to try and see if I could change the arrangement to make it move further for less energy. So these are different examples of what you could potentially do in your studies. There's a lot more to it, but we can always chat about it at a later stage, hopefully. So that was me, and I graduated in 2019, and I then moved on to work. So I first started in yachting. So I started designing super yachts in a company based in Southampton. And I started getting involved into resistance of propulsion. So I started looking at how can I design this shape that moves in water, and how can I make it more efficient to move for less energy, and what kind of processes can we come up with to create tools to use the knowledge we have in a company to try and speed up the process to calculate things. Another thing I was involved in that comes hand in hand with that is renewable energy. So how can we make these big structures as clean as possible? How can we change the systems? How can we change the arrangement? What kind of fuel can we use? Should we use electricity? Can we use solar panels for certain things? And so I got very much involved in the energy transition, essentially, where we want to reach net zero and try and improve our designs, and not just improve, but try and offer an option where an existing boat can actually change their current design and adapt to also reduce their emissions. So that was another thing I was involved in, which is very much overall what a naval architect could potentially do in different fields. Within that, technical drawings, every engineer, regardless of what engineering you get into, you will be at some point involved in drawing up things. If we're manufacturing things, you got to draw it up. Whoever needs to make it needs to understand what are the dimensions, how does it look, should I cut here, should I cut there, main parameters, main dimensions that a manufacturer needs to produce a product. Weight surveying, I did mention, so mass and buoyancy, so the balance of forces of these structures basically will tell you how it reacts in water, and what kind of overall design you need to support a certain load. So if I'm a container ship and I'm carrying goods, I'm carrying fruit and vegetables from one side of the world to another, how much do these goods weigh? How big a boat do I need to design my structure for to support this weight? Concepting, as I said, everything starts with an idea. You need to evaluate how that idea is going to develop. And then regulations, everything needs to be double and triple checked. So if we get an external organization that checks everything for us and approves everything for us, then we are assured that what we're doing is correct, it's safe, and it's at a good standard. So moving on from there, where am I at now? So I've changed slightly my field, and I'm still a naval architect, but I'm working for underwater technology. So our aim is to try and make humans aquatic. So what does that mean? We're not going to grow gills, unfortunately. We're not going to become fish, but we are going to try and get as close as possible with engineering. So this is a concept of the, which actually is not only a concept. There is a lot of engineering done to this project, but it's essentially the largest structure that we are intending to design. And essentially the purpose of it is to set some form of like capsule shape, as you can see there, structure that will be set on the seabed underwater at a maximum of 200 meters, and 6 crew members can live and work in there for almost a month. So this structure is designed with science labs inside, with crew quarters, so cabins, with a kitchen, with a common area, and you can basically dive in and out of it for a maximum of 21 days. And you can conduct research and collect samples and communicate with people at the surface, and you can remain underwater to explore the ocean for a substantial amount of time. So this is currently what I'm working on, which is essentially starting from a smaller version of it, which is here at the top right, which is a smaller version that will fit 3 crew members. And we will test this in our campus, which is a quarry that naturally has filled with water. And essentially, it's a big man-made pool where we're going to test these structures. Now, this structure is a considerably heavy structure. It's almost 50 tons. And the naval architect for a project of this sort would be very much involved in the balance of forces of these things. Why? Because the secondary main job a naval architect has with marine products is powering and resistance, but In this case, the structure is not a submarine. It will not move. It will be fixed. So there are other areas that a naval architect will have to tackle with a design like this. So apart from that, another thing I'm involved in is submarines that we actually already have in-house. So we have these two submarines here that are in the picture are not precisely the ones we have, but they are the exact same type. And so I've been working to correct the balance of forces of these subs, and I've carried out some testing for them, added some buoyancy to it, and corrected for the use of it in a different water. So I've gone from seawater to freshwater, and the naval architect will be involved in testing of those, and funny enough, diving in them as well, which has been very exciting. So that's a summary of what I've been involved in. I can dig deeper if we've got time, and I can stop if we're short in time.
Time for a few. The first question that's come in is, do you have to train as long for deep water work as you do for going into space?
That's a very interesting question. So I think it depends how deep you go. So there is a lot of knowledge and training that has already happened. We have already procedures in place for, we have practice, we have experience for diving at a certain depth. And I'm not a diver myself, especially to those depths. But top of my head, I know that we have been diving to up to about 150 meters with as a sort of standard, similar to a standard scuba diving gear. And we've been going, these subs I'm showing here go up to 1,000 meters. But when it comes to deeper depths without a submarine, we are probably in a phase where we know as little as people know to go to space, which will probably involve a similar amount of training, which is surprising because you would think space is much more complex than doing something on planet Earth, but we actually don't know anything about our oceans past a certain depth. And this is the reason why we're designing these structures to begin with. And that will involve a lot of training, which won't be far from the amount of training people going to space will need, because we are going into the unknown.
And I've got a question here from Sarah Toyloco. I think it's how long does it take to design yachts?
So that is another very good question. That will depend on a lot of factors. Assuming on average, assuming everything goes well, things are agreed on, from the very start of a potential owner having an idea in mind, they will then go to a design firm. The design firm will design something for them, an idea on paper, modeled in 3D, and that will then be sent to an engineer, construction. There will be lawyers involved, there will be contracts, construction will need to be complete, testing, etc. All of that, on average, might take, with a yacht of, say, 80 meters and above, would probably not take less than 5 or 6 years.
Okay, interesting. Janafia Khan says, what do you like about subsea engineering? I guess what are some of those weird challenges I guess you face too?
Oof, yeah, what do I like? So I like the unknown. I like I'm helping design with a lot of people in our team, not just myself, but I'm helping design something that will eventually get us to discover something that no one else has seen before. That's what I like.
And Walkergate 4B, what special equipment would you have to wear to live there? I think they're talking in what looks like the sort of Gungan city from Star Wars, those pods. What equipment would you need?
So inside the capsule, you will be, and this is probably a funny one actually, not just what you wear, but So basically, inside you can probably wear standard clothes, and that is possible because of the complex systems that are in place for controlling the environment inside, being the air you breathe, or the gases you breathe in this case, and the temperature. So you are under a lot of pressure in there, because you're at a certain depth, and you're actually breathing past a certain depth. You're actually breathing a mix with helium, which means that everybody inside is dressed very normally, but speaks with a very squeaky voice. So when you're outside of that structure diving, you will need a specific diving suit with potentially an umbilical, which is essentially a tube connected to your suit that allows you to breathe. And it will also have cables to allow for comms, and it will also have heating. So it might have hot water pumping around your suit when you're outside of the structure. Inside, you can dress normally, as long as your systems maintain the right environment for you to live in.
I got a question in here from Louis. What are the current issues that you're trying to solve before this is all possible?
So there are a lot of things that need to be resolved, which is why we've got a lot of engineers involved with a diverse background. One particular issue we've got that is quite interesting, that a naval architect will definitely be involved in, is how do we get this in the water and out? Because up until now, especially in the offshore sector, it's been very interesting to reach a point where you set something in the water, but no one's ever cared about how to remove it. And we do not want to be disturbing our environment. We want to be there to explore and protect our environment. So one of the big issues that we need to resolve right now is what supporting systems, say a boat, a crane, what supporting assets do we need to launch this in the water and recover it without causing any damage or footprints in our oceans.
Well, we've got time for one more question. Thank you so much, everyone, for your questions. But Miss Ma asks, do you have any advice for youngsters starting in this career and perhaps do maybe naval architecture?
My advice is be curious. Be curious and go for what truly excites you. There's nothing more rewarding than pushing through a career decision or life decision, regardless of what it is, with something that you're curious and you're interested in. That's my advice.
And a quick one-liner, what's your favorite part of a ship from 3C?
Ooh, my favorite part of a ship, the sauna. Just a joke. My favorite part of the ship, I think it is the engine room, especially when it's not fully equipped. You can see the propulsion system, so you can see the propellers of a ship, which are humongous, and you can see them from inside, all linked to every single system. And it's something that is very hard to see when everything is all decorated and covered up. I think that's probably my favorite part of having actually been myself in a ship.
Well, Andrea, it's been absolutely fascinating, and we have loads of other questions. So, clearly everyone found it fascinating too. And thank you, everybody, for your questions. Sorry to those who we didn't get to, but very much appreciate you joining us. And special thanks to you, Andrea, for inspiring all of the engineers in the making out there. Now it's your turn to come up with your own engineering ideas. And remember, send them to us once you're finished so we can get your certificate sent out and hopefully see you in person at our public exhibitions at the end of the school year. Remember, as soon as you've got your ideas designed in class, send them over to us. Thank you to everybody. And thanks again, Andrea. And remember, if you were an engineer, what would you do?